Assalamualaikum students. In this lecture, we will solve exercise 2.1 and it's question number 8. We will only solve one question. It has two parts because this question requires a lot of your attention. Question number 8 states, show that the roots of the following equation are rational. We have to prove that whether the roots are rational or not. If b square minus 4ac is greater than 0 and is a perfect square, then the roots are rational. The roots are rational when we have a perfect square. So applying all the methods on the given equation, our answer should be in a perfect square. If the answer is perfect square, we will say that yes, the roots were rational. So we will apply the same method first. We will take the values of a, b and c. After taking the values of a, b and c, we will apply discriminant. Here discriminant won't be equal to 0 because as we can see here, the roots are rational when the discriminant is greater than 0. So we won't put the sign of greater. A is A into B minus C, B is to B into C minus A, and C is C into A minus B. Applying this instead of A, B and C in the formula, we have written B into C minus A whole square minus 4 into A into B minus C and C into A minus B. We will open the square. B is the square of itself, so B square will be same, and C minus A, that's taking the square of C minus A, it will be C square plus A square minus 2AC. Minus 4 will remain the same. A into B is AB and A into C is minus AC. C into A is AC and C into minus B is minus BC. Now we will open the brackets. We will multiply B square with C square. It will be B square C square. B square with A square. It will be A square B square. And B square with minus 2AC. It will be minus 2AB square C. Minus 4. First of all, we have to multiply AB minus AC with AC minus BC. So the answer will be A square minus B square minus AB square C minus A square C square plus AB C square. In the next step, we will multiply minus 4 with all the digits inside the bracket. So because of that minus, we have to change the signs. Minus to plus and plus to minus. So the equation will become b square c square plus a square b square minus 2ab square c minus a square bc plus 4ab square c plus 4a square c square minus 4ab c square. This is the last step. Now look for the common terms. The common terms are the terms whose variables are having the same powers. So minus 2a b square c and 4 plus 4a b square c are the only common two digits. All the other digits are not common to each other, so they won't be added or subtracted. So minus 2ab square c and plus 4ab square c will change to plus 2ab square c. So first digit b square c square will remain the same, a square b square. So now this will be replaced by plus 2ab square c square, and we won't write this minus 4a square bc plus 4a square c square and minus 4a bc whole square. Then the next step is of the arrangement. I have taken b square c square first and a square b square to the third step and 2abc square in the middle because this is a square plus 2ab plus b square. I have written the term which is a perfect square in the first place and in the third place. Now talking about these three digits, 4a square bc and 4abc square. These two are having all the three variables with it, a, b and c, a, b and c. So these two will be written together, 4a square bc and minus 4ab c square. 4a square c square will go to the end because this is also a perfect square. Applying the formula of perfect square to the first three terms, we will get bc whole square plus 2 into bc into ab plus ab whole square, which is a square plus 2ab plus b square minus, I have taken common from these two terms, 4abc is the common digit. So from the first term we get a and from the second term we get c. As we have taken minus sign outside the bracket, so this minus has been changed to plus and 4a square c square will remain the same. We will close this bracket. This is a plus 2a square plus 2ab plus b square. So I will close it and it will become a plus b whole square. So bc plus ab whole square minus, this will also remain the same, and now I have changed 4a square c square to 2ac whole square. Now you can see the first digit is a square, the last digit is a square. So can I say this is a square and this is plus b square? So this term will become minus 2ab term, a square minus 2ab plus b square. Is it so? Yes, we will apply the formula of a square minus 2ab plus b square, and the formula will be a minus b whole square. Taking b common from here, you can take common, or if you don't want to, that doesn't matter. B into c plus a whole square minus 2 into a, which is this, into b, which is 2ac plus 2ac whole square. Now we will close it. First of all, look, 2 into 2 is 4. This AC and this B will become ABC, and C plus A is equals to A plus C. So this is, after multiplication of all this, we get the central term. It means that the perfect identity, perfect square identity can be applied. So the formula is a square minus 2ab plus b square, and it will close to a minus b whole square. A was b into c plus a and b was 2ac whole square. As b into c plus a minus 2ac whole square is a perfect square, so the roots are rational. Coming to the second part of question number 8, again we are having an equation of x square x and a constant term. We will again take the values of a, b and c, which is a is a plus 2b, b is 2 into a plus b plus c, and c is a plus 2c. We will apply the discriminant b square minus 4ac. Instead of b square, we will write 2 into a plus b plus c whole square minus 4 into a plus 2b into a plus 2c. Taking the square of 2 is 4, and the square of a plus b plus c is b. We are going to use another formula, which is a plus b plus c whole square equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. You have studied that formula in 9th class, and as the formula is same as applied in the question, so I have not written it separately. So a square plus b square plus c square plus 2ab plus 2bc plus 2ca minus 4 will remain the same. First we will multiply the brackets. It will become a square plus 2ac plus 2ab plus 4bc. Now we will multiply the brackets from multiplying the first bracket with 4 and the second bracket with minus 4. Here you can also do that. You can take 4 as a common digit and then you can solve the brackets. Both the solutions are correct. So I have multiplied the 4 with the digits inside the brackets first. So 4a square plus 4b square plus 4c square plus 8ab plus 8bc plus 8ca minus 4a square, because minus is going to multiply with the digits inside the bracket, so the signs will get changed. So minus 4a square minus 8ac minus 8ab and minus 16bc. 4a square and minus 4a square will get cancelled, nothing remains. 4b square, there is no common digit, so 4b square will be written here. 4c square, there is no common digit, so it will also be written here. 8ab plus 8ab and minus 8ab will also get cancelled, so we won't write it. Plus 8bc and minus 16bc, the answer will be minus 8bc. Plus 8ca and minus 8ca will also get cancelled with each other, so nothing remains. We can take 4 as a common digit again. B square plus c square minus 2abc, so you can see that a square plus b square minus 2ab. Now we will apply the formula of perfect square. 4 is the square of 2 and a square plus b square minus 2ab, b square is the square of b, c square is the square of c, and 2bc will be changed to 2 into b into c. A square plus b square minus 2ab will be a minus b whole square, where a was b and b was c. As we have the square on both the digits, so we can write it all together, that is 2 into b minus c whole square. Again, we are having a perfect square, it means the roots are rational. 2 into b minus c whole square is a perfect square, so the roots are rational.